Hey kids, welcome to section 4.2 Powers of Binomials. Today I'm going to teach you how to use Pascal's triangle to expand powers of binomials, and then how to use the binomial theorem to be able to expand powers of binomials. Now, there is a long way and a short way that you can multiply out binomials. This thing in front of you is called Pascal's triangle, and Pascal's triangle is useful in shortcutting the expanded form of binomials. For instance, if I asked you to do x plus y quantity squared, you'd go, oh, x plus y, x plus y. You will double distribute and get x squared plus 2xy plus y squared. Okay, no big deal. If I asked you to do x plus y cubed, you'd have to take what you just got for x plus y squared, and you would have to multiply by x plus y. And so you get x to the third, you'd have x squared y and 2x squared y, which is 3x squared y. Then you'd have 2xy squared and another xy squared, which is 3xy squared. And then you'd have y cubed. So I did a lot of that in my head. But that takes a long time to do, especially if I did x plus y to the fourth, it would get even crazier. So notice a pattern that right here in this row is the numbers 1, 2, and 1. And look here, I have the numbers 1, 2, and 1. And notice that it's the second power, and that is this one right here. This is the third power, which is this row. Notice the numbers are 1, 3, 3, 1. And here I have 1, 3, 3, 1. Ooh, pretty cool. Now, the exponents, notice in the x plus y squared that I have x2, and then I have x1, y1, and y2. So notice the powers of x go down, 2, 1, and x to the 0. It's not there. And then notice the powers of y go up. Y to the 0, y to the first, y to the second. If you look at x plus y quantity cubed, you have x to the third, y to the 0. Then you have x to the second, y to the first. Notice the exponents go down. 3, 2, 1, 0. And then 0, 1, 2, 3. So it's pretty easy to be able to expand these without actually having to do any of the multiplication. This goes up to the 11th power. So this down here would be x plus y to the 11th power. Notice that if you have 11th power, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 terms. So that's one more than the power. Notice that if I had x squared, I had 3 terms, which is one more than the power. So every time you always have one more term than the power. All right, so we're going to refer back to this triangle a lot. Let's see how we can use it. So I knew to expand a plus b to the 7th power. Well, I could keep doing what I was doing, or I can use Pascal's triangle. So the 7th row is what I need to grab the coefficients from Pascal's triangle. The 7th row is right here, 1, 7, 21. I'm just going to put them up here. 1, 7, 21. 35, and then it repeats because it's symmetric. 35, 35, 21, 71. Okay, I put those there so I wouldn't have to keep going back and forth. All right, so what we're going to do is we're going to take these coefficients and we're going to put them in front, and then we're going to take the first thing and bring it to the first power, a to the 7th, and we're going to do b to the 0 plus. Then we're going to take the next coefficient, 7, and we're going to go down a power with a, and we're going to go up a power with b. Then we're going to grab the next coefficient, 21. We're going to go down a power of a, up a power of b, plus the next coefficient, down a power of a, up a power of b, plus the next coefficient, down a power of a, down a power of a, up a power of b, plus the next coefficient, 21, down a power of A, up a power of B. Next coefficient is 7, down a power of A, up a power of B. Next coefficient is 1, down a power, up a power. So notice every time that the degree of each monomial is 7. 7 plus 0 is 7. 6 plus 1 is 7. 5 plus 2 is 7. 4 plus 3 is 7, and so on. Now I can clean it up a little bit because anything to the 0 power is 1. So I'm going to get a to the 7th. I'm going to get 7a to the 6th b. I'm going to get 21 a to the 5th b squared plus 35 a to the 4th b cubed plus 35 a to the 3rd b to the 4th plus 21 a squared b to the 5th plus 7a b to the 6th plus b to the 7th. And this is my expanded form. It would take you way longer if you actually did it completely by hand. Okay, letter B, x minus 3 to the 4th power. So I'm looking for the 4th row, find the 4. So 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. All right, so we have 1, and then we do the first letter, x to the 4th power, and we do negative 3 to the 0 power, plus. The next coefficient is 4. I go down a power of x, and I go up a power of negative 3, plus. Grab the 6, go down a power of x, go up a power of negative 3, plus 4, go down a power of x, and go up a power of negative 3, plus 1, go down a power of x, go up a power of negative 3. Remember, my exponents should always be the same. In this case, it's always going to be 4. Now we simplify. Well, negative 3 to the 0 is 1, and so I have x to the 4th. Then I have negative 3 times 4 is negative 12x cubed. Then I have 9 times 6 is 54x squared. Negative 3 cubed is negative 27 times 4 gives me negative 108x to the 1st. And then I have x to the 1st is 1, negative 3 to the 4th is 81. So again, we used the pattern of going down by a power of 1, going up by a power of 1. Notice that this negative in the parentheses, I kept with the 3, and then make sure you're very careful when you're taking negative numbers to powers. All right, well, now we have coefficients other than 1. So now we're sticking numbers in front of the variables. Same process. So I need the 4th row, which we just did was 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. All right, so I do 1. Then I do the first thing to the 4th power. So in this case, it's going to be 5 to the 4th, a to the 4th. And then I do the second thing to the 0 power. Plus. Then I have 4. I take the 5a down a power. And I take the negative 4 up a power. Then I have 6. I take 5 down a power. And I take negative 4b up a power. Plus 4, take 5 and a down a power. Take negative 4 and b up a power. Plus 1, take 5 and a down a power. Take negative 4 and b up a power. So notice that my exponents are always totaling 4. All right, so let's clean this up a bit. 1 doesn't matter. This -4 to the 0, b to the 0 doesn't matter. 5 to the 4th is 625, a to the 4th. Then we have 4 times 5 cubed times -4 to the 1st. That's -2000, a cubed b. Then we have 6 times 5 squared times -4 quantity squared. That's going to give us 2,400, a squared b squared. Then I have 4 times 5 times -4 to the 3rd. That's -1,280, ab cubed. And then the 1 doesn't matter, the 5 to the 0, a to the 0 doesn't matter. -4 to the 4th power is +256, b to the 4th. So notice all my powers are totaling 4 in each of the monomials, and notice that my powers or my signs also fluctuate between positive and negative because it started with a negative in the problem. It starts with a negative as your first sign change, then positive, then negative, then positive. So that should always happen if one is positive and one is negative. All right, let's look at B, 3x plus 2y to the 5th. So I need the 5th row. So I go to Pascal's triangle. I need the 5th row, 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. So I take the coefficient 1, and I raise the first thing to the 5th power, and the second thing to the 0 power. Plus, take the next coefficient 5, take the 3 down a power, and the x down a power, take the 2 up a power, and the y up a power. Plus, grab the next coefficient 10, take the 3 down a power, the x down a power, and take the 2 up a power and the y up a power. Plus, grab the next coefficient 10, take the 3 down a power, the x down a power, take the 2 up a power and the y up a power. Plus, the next coefficient is 5. Take the 3 down a power, the x down a power, take the 2 up a power and the y up a power. Plus, the next coefficient is 1. Take the 3 down a power, the x down a power, but take the 2 up a power and the y up a power. So then we simplify. This is 1. This quantity is 1. So we have 3 to the 5th, which is 243 x to the 5th. Plus, and I have 5 times 3 to the 4th times 2 to the 1st. That's 810. And then x to the 4th, y to the 1st. Plus, I have 10 times 3 cubed times 2 squared. That's 1080. And I have x cubed, y squared. Plus 10 times 3 squared times 2 cubed. That's 720. That's pretty bad. 720 x squared, y cubed. Then I have 5 times 3 to the 1st times 2 to the 4th. That's 240. X to the 1st, y to the 4th. And then I have that's gone. And then 2 to the 5th is 32. Y to the 5th. So as you can see, these are quite ugly, but it's all a huge pattern. Big pattern. All right, so what if I don't want to expand the entire thing, but I just want a specific term? So for instance, in letter A, I want the fifth term if I were to expand y plus z to the 11th power. Now, in order to do this, you need to find what the coefficient is of the fifth term in the 11th row. So go to your Pascal's triangle, find the 11th row, which is down here. Find the fifth coefficient. 1, 2, 3, 4, 5. It's 330. So we're going to have 330. And the fifth term, think about the fact that there are 12 terms if it's to the 11th power. And so the fifth term would be y to the 12 minus 5, or 7. And then z would be to the fourth because I have to have a total of 11. So again, to find that y to the 7th, you could look at the 11th row and think to yourself, okay, here's y to the 11th, here's y to the 10th, y to the 9th, y to the 8th, y to the 7th. And so that's how I got the y to the 7th. And then I knew that my z had to total 11 when added with the 7. So that's how I got the 4. All right. If I do letter B, I want the third term of 3a minus 5b to the fifth. Okay, so let's go to the fifth row and find the third term to get the coefficient. Fifth row, third term. Fifth row, 1, 2, 3. It's a 10. Fifth row, third term is a 10. So I have 10. Then if I have to the fifth power, I have 6 terms. 6 minus 3 is third. So I'm going to take 3 to the third and a to the third, which means I'm going to have negative 5 squared b squared because my exponents have to total 5. All right, well, 10 times 3 cubed times negative 5 squared is 6,750. A cubed b squared. Okay. So this last slide just has a review in it. In a binomial expansion, a plus b to the nth, there are n plus 1 terms, like we just saw. N is the exponent of a in the first term and b in the last term. In successive terms, the exponent of a decreases by 1 and the exponent of b increases by 1. The sum of the exponents in each term is n, and the coefficients are symmetric. So that's how you do section 4.2. If you guys have any questions, please reach out to me. And as always, keep calm and keep trucking.